Namaste dear children, I am Rekha. Welcome to my channel Rekha's Knowledge Hub. Today we will see NCERT Class 6 Maths, Chapter 6 Perimeter and Area, last part. Area of a triangle. Draw a rectangle on a piece of paper and draw one of its diagonals. Cut the rectangle along the diagonal and get two triangles. So, you take a piece of paper and draw a rectangle on it. And then you draw one of its diagonals. See this picture like this. First you draw a rectangle, then you draw one of its diagonals. Then cut the rectangle along that diagonal. You will get two triangles. Check whether the two triangles overlap each other exactly. Do they have the same area? Then you keep the triangles in such a way that the two triangles overlap each other. Do they overlap each other exactly? Why? Yes, when you cut a rectangle along its diagonal, you get two triangles that do overlap each other exactly and have the same area. They have same area. Try this with more rectangles having different dimensions. You can check this for a square as well. Now, see the figures below. Is the area of the blue rectangle more or less than the area of the yellow triangle? Or is it the same? Why? See this picture, this blue rectangle, and you can see a yellow triangle. Then what about their areas? Area same or not? Same. This is because the diagonal splits the rectangle into two equal parts, making the triangles congruent. When you cut the rectangle along its diagonal, you will get two equal parts. So, the triangles will be congruent. Congruent means having the same shape and size. If you were to place two congruent figures on top of each other, they would perfectly overlap. Can you see some relationship between the blue rectangle and the yellow triangle and their areas? The area of the blue rectangle is equal to the yellow triangle. Use your understanding from previous grades to calculate the area of any closed figure using grid paper and find the area of blue triangle BAD. So, to calculate the area of a closed figure using grid paper, simply count the number of grid squares that are fully or mostly covered by the figure, considering each square as one unit of area. So, if a square is completely covered by figure, then it is taken as 1 unit. If it is covered more than half, then also it is considered as 1 unit. Then if a square is covered by half, then it is taken as half unit. Then if the square is covered by less than half of the figure, then it is not taken at all. So, first one, find the area of the blue triangle BAD. So, we have to find the area of triangle BAD. See, this is BAD. See, we can count like this. So, how many units are there? Total 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 units. Then next, find the area of red triangle ABE. We have to find the area of red triangle. So, we can fill like this. Okay. So, it is also 10 units. So, squares which are covered by the figure by less than half, they are not taken. Okay. Both the red and blue triangles have the same area, but they look very different. Then, what is the area of rectangle ABCD? See. So, what's the area of rectangle? How many units are there? 20 units. So, the area of triangle BAD is half the area of the rectangle ABCD. BAD is only 10 units. Then, what about rectangle? It is 20 units. So, area of triangle BAD is half the area of rectangle ABCD. Area of triangle ABE is equal to area of triangle AEF plus area of triangle BEF. See, area of triangle ABE, this red triangle, it is equal to the area of triangle AEF. See this one, AEF plus area of triangle BEF. Okay. Here, the area of triangle AEF is equal to half of the area of rectangle AFED, this rectangle. Then, similarly, the area of triangle BEF is equal to half of the area of rectangle BFEC, this rectangle. Thus, the area of triangle ABE is half of the area of rectangle AFED plus half of the area of rectangle BFEC. That is half of the sum of the areas of the rectangles AFED and BFEC. That is half of the area of rectangle ABCD. Then what is the conclusion? The diagonal of a rectangle divides the rectangle into two equal parts. The area of each triangle is half the area of the rectangle. Figure it out. Find the area of the figures below by dividing them into rectangles and triangles. So some figures are given. We have to find the area of these figures by dividing them into rectangles and triangles. See the rules. Fully filled squares, they are taken as 1 square unit. Half filled squares, they are taken as half square unit. More than half filled squares, they are taken as 1 square unit. Less than half filled squares, we have to ignore those squares. See the first figure. How many fully filled squares are there? See 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So fully filled squares are 20. Then more than half filled squares, how many squares are there? See, we have 1, 2, then 3, 4. So, more than half filled squares, 4. Then, less than half filled squares, we have to ignore. Okay. So, total area is 20 into 1 plus 4 into 1. So, it is 24 square units. Similarly, you have to do the rest of the figures. See the figure B. How many fully squares are there? 25 fully filled squares are there. Then more than half filled squares 4. Total area 25 into 1 plus 4 into 1, that is 29 square units. Okay. Next one. See the next figure, figure C. How many fully filled squares are there? 36. More than half filled squares 8. Half filled squares 2. Total area 36 into 1 plus 8 into 1 plus 2 into half. That is 45 square units. Then figure D. Fully filled squares 13. More than half filled squares 3. Total area is 13 into 1 plus 3 into 1, that is 16 square units. Then next figure, figure E, fully filled squares 5. More than half filled squares 4. Half filled squares 4. Total area 5 into 1 plus 4 into 1 plus 4 into half, that is 11 square units. Making it more or less. Observe these two figures. Is there any similarity or difference between the two? Observe these two figures. Using 9 square units, having an area of 9 square units, we have made figures with the two different perimeters. The first figure has a perimeter of 12 units and the second figure has a perimeter of 20 units. See the first figure, what about the area? It is 9 units, 9 square units. Then second figure, also 9 square units. What about the perimeter of first figure? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12. Then what about the second figure? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 units. Then arrange or draw different figures with the 9 square units to get other perimeters. What is the condition? Each square should align with at least one other square on at least one side completely. And together all squares should form a single connected figure with no holes. There should not be any hole. Okay. Using 9 unit squares, solve the following. What is the smallest perimeter possible? To minimize the perimeter, we want to arrange the 9 squares in a compact shape. The most compact arrangement is a 3 by 3 square. So what is the dimension? 3 units by 3 units. Then perimeter 4 into side, 4 into 3. It is a square. So 4 into 3, 12. Okay. Then what is the largest perimeter possible? Largest perimeter. To maximize the perimeter, we want to stretch the shape as much as possible. The most stretched arrangement is a 1 by 9 rectangle. So dimension is 1 unit by 9 unit. Perimeter is 2 into length plus width, that is 2 into 1 plus 9, that is 20 units. See this picture. The next one, make a figure with a perimeter of 18 units. See this figure. What's the perimeter? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. The next one, can you make the other shaped figures for each of the above 3 perimeters, or is there only one shape with that perimeter? What is your reasoning? For smallest perimeter, only 3 by 3 is possible. But for the other 2, other shapes are also possible. What's the reason? The minimum perimeter is achieved by arranging the squares in the most compact shape. Maximum perimeter is achieved by stretching the shape as much as possible. This often results in a long, thin rectangle. Below is the house plan of Charan. It is in a rectangular plot. Look at the plan. What do you notice? Some of the measurements are given. Find the missing measurements. Also find out the area of his house. See this room, this is master bedroom. It is 15 feet by 15 feet. That is, length is 15 feet and width is also 15 feet. 15, 15. Area is given. Area is 225 square feet. 15 into 15, that is 225 square feet. Then see the next room. It is a small bedroom. See here it is 15 feet. Length is 15 feet. Breadth we have to find. Area is 180 square feet. So area of small bedroom is equal to length into width. That is 180 is equal to 15 into width. What is width? Width is equal to 180 divided by 15. That is 12. So here width is 12. Length is 15. 12, 15. Area is 180 square feet. Okay. See the next one. It is garden. Garden. Measurements we have to find. See. The total width. It is 30. 30 feet. Here it is 15. Here it is 12. So, 15 plus 12. That is 27. So, 30 minus 27 is 3. See, here it is 3. Then what about the length of the garden? See, up to here it is 15. Here it is 15. We have to find the remaining length. Okay. Then see the toilet region. It is 5 feet by 10 feet. See, 5 feet by 10 feet. 10 feet length, 5 feet width. So here also it is 5. So length of the garden is 15 plus 5 is equal to 20. So what's the area of the garden? 20 into 3, that is 60 square feet. Okay. The next one, see the kitchen, it is 15 feet by 12 feet. 15 feet length, 12 feet width. Area is given, it is 180 square feet. Okay. The next one, utility region. See, we have to find the measurements. See, the total width of the plan is 30 feet. House is 30 feet. Okay. So, see, up to here it is 15. It is given. So, 15 minus 12 is equal to 3. Width is 3. Okay. Then, its length is 15. See, this length is 15. Okay. Then, area is 15 into 3, that is 45 square feet. Next, we have to find the area of hall. We can divide this hall into two regions like this. A square, 5 by 5 square, and then the another region. So, area of square is 5 into 5, 25 square feet. Then, what are the rectangle, area of rectangle? Length into width, that is, here it is 20 into 12. See, 5 plus 15, that is 20. Then 20 into this region is 12. Okay. So 20 into 12, 240 square feet. So the total area of hall is area of square plus area of rectangle, that is 25 plus 240, that is 265 square feet. So area of hall is 265 square feet. Then parking. Area of parking is 15 into 3. How did you get? See, this region is 3. Width is 3. Then, what about this length? It is 15. The same length. 15. Okay, so 15 into 3 is 45 square feet. Then, total area is equal to 225, that is master bedroom area, plus 180, that is small bedroom area, plus 60 garden area, plus 45 parking area, plus 265, that is area of hall, plus 45 utility area. Then 100 plus 180, that is kitchen area. Then plus toilet area, that is 50. So total 1050 square feet. Now find out the missing dimensions and area of Sharon's home. Below is a plan. So we have to find the missing dimensions and we have to find the area of Sharon's home. Some of the measurements are given. Find the missing measurements. Find out the area of his house. So what's the area of master bedroom? It is 12 into 15. That is 180 square feet is given. See here 12 feet by 15 feet. Okay, so 12 into 15, 180 square feet. Then this kitchen, it is 18 feet by 10 feet. So length 18, width 10, area is 180 square feet. Okay. Then next one, utility region. What's the area of utility region? Length into width. Here Length is given as 10. Area is given as 70. We have to find the width. So 70 is equal to 10 into width. So width is equal to 70 by 10, that is 7. So width is 7. See. Then next one. We have to find the area of toilet. See, width is 42. Width is this region. This is 42 minus 12 plus 18 plus 7. Okay, that is 42 minus 37. It is equal to 5. So width is 5. Then what about length? Length is 10. This same length. Okay, 10. So toilet area is 10 into 5, 50 square feet. Next, area of small bedroom is 12 feet by 10 feet. That is, area is equal to 12 into 10, 120 square feet. Next one. So, 12 length, width is 10 for small bedroom. Next one. Hall 23 feet. Length is given as 23 feet. We have to find the width and area. Width of hall is 10 plus 5. That is 15. See, up to here it is 10. Then, see the master bedroom, its length is 15. So, 15 minus 10 is 5. So, this region is 5. So, 10 plus 5 is 15. So, what about area? 23 into 15, that is 345 square feet. Then, entrance, area of entrance is 15 into 7. See, width is 7. The same width here, 15. Sorry, 7. And the length is 15 here. See, here it is 15. Here also it is 15. So, 15 into 7, 105. Then total area is 180 plus 50 plus 180 plus 70 plus 120 plus 345 plus 105. That is 1050 square feet. What are the dimensions of all the different rooms in Sharon's house? Compare the areas and perimeters of Sharon's house and Charan's house. Okay, perimeter of Charan's house is 2 into 35 plus 30. That is 130 feet. Perimeter of Sharon's house is 2 into 42 plus 25. 42 plus 25 is 67. So 2 into 67 is 134 feet. Area maze puzzles. In each figure, find the missing value of either the length of a side or the area of a region. See this figure. First region, it is 13 square centimeter. So 13 means 1 by 3. See, length is 13 and width is 1. That is 13 by 1. That is 13 square centimeter. See the next one, 26 square centimeter. See, here it is 13. So 13 by 2 is 26 square. 13, here it is 2. So 13 by 2, it is 26 square centimeter. The next one, here it is 1. So here the area is given as 15 square centimeter. So this side will be 15. So 15 by 1, that is 15 square centimeter. And here this region is 15 by 2. Why? See, here it is 15, here it is 2. 15 by 2, that is 30 square centimeter. Next figure. See, here it is 10 square centimeter. 10 square centimeter is, here it is given as 2. Up to here it is 3. 10 square centimeter is 2 into 5 is 10, right? So 2 by 5. So this remaining region is 2 centimeter. So 2 by 5 is 10 square centimeter. Then next one, here it is 10 square centimeter. See, 10 square centimeter means here it is given as 2. So, 2 by 5. Up to here it is 2. So, here it is 3. So, 5 by 2, that is 10. 10 square centimeter. The next one, here, up to here it is 3 centimeter. Then what about the width? Width is 3. It is already given 3. So, area is 3 by 3. That is 9. 9 square centimeter. See this figure. In the middle rectangle, area is 42 square centimeter. Its width is given as 6 centimeter. So, we have to find the length. Length into width is 42. That is, length into 6 is 42. What is length? Length is 7. So, 7 into 6 is 42. See, 7 into 6 is 42. Okay. See, up to here it is 3 centimeter. Then what will be the width of the first rectangle? 7 minus 3, that is 4. Okay. Then see the third rectangle, its area is given as 60 square centimeter. Okay. What is its length? Here it is 7. So 7 plus 5 is 12. 12 into dash is equal to 60. That is 12 into 5. So here it is, width is 5. Okay. Width is 5. So what will be the area of first rectangle? First rectangle is width is given as 4. We have to find the length. So total it is 15 centimeter. Up to here it is 15. Then 6 plus 5 is 11. So up to here it is 11. So 15 minus 11 is 4. So area is 4 into 4. It is square. 4 into 4 is 16. 16 square centimeter. Next figure. See this rectangle. Its length is 5 centimeter. Area is 18 square centimeter. So we have to find the width. Width is equal to 18 divided by 5. That is 3.6 centimeter. So width is 3.6 centimeter. So here it is 3.6 centimeter. Here it is 4 centimeter. So the length of this rectangle is 4 plus 3.6. That is 7.6 centimeter. Then its area is 38 square centimeter. So its width is 38 divided by 7.6, that is 5 centimeter. Give the dimensions of a rectangle whose area is the sum of the areas of these two rectangles having measurements 5 meter by 10 meter and 2 meter by 7 meter. So we have to find the area of a rectangle. The area is equal to the sum of the areas of two rectangles having measurements 5 meter by 10 meter and 2 meter by 7 meter. So area of first rectangle is 5 into 10, 50 square meter. Area of second rectangle is 2 into 7, that is 14 square meter. Sum of the areas of two rectangles is 50 plus 14, that is 64 square meter. So dimensions of the rectangle can be 16 by 4 or 32 by 2 or 1 by 64. Okay. The area of a rectangular garden that is 50 meter long is 1000 square meter. Find the width of the garden. So, there is a rectangular garden. Its length is 50 meter and its area is 1000 square meter. We have to find the width of the garden. So, area of the rectangular garden is 1000 square meter. Length of garden is 50 meter. Therefore, width of the garden is equal to 1000 divided by 50, that is 20 meter. The floor of a room is 5 meter long and 4 meter wide. A square carpet whose sides are 3 meter in length is laid on the floor. Find the area that is not carpeted. So, we have a floor, it is 5 meter long. See, this is 5 meter long and its width is 4 meter. Then a square carpet is laid on the floor like this. The sides are 3 meter in length. See, 3 meter. Find the area that is not carpeted. So we have to find this area that is not carpeted. Okay. So length of room is 5 meter. Width of room is 4 meter. Area of rectangle is 5 into 4, that is 20 square meter. Side of square carpet 3 meter. Area of square carpet 3 into 3, 9 square meter. Area that is not carpeted 20 minus 9, that is 11 square meter. 4 flower beds having sides 2 meter long and 1 meter wide are dug at the 4 corners of a garden that is 15 meter long and 12 meter wide. How much area is now available for laying down a lawn? So, there is a garden, its length is 15 meter and its width is 12 meter. Then 4 flower beds are arranged at the 4 corners of this garden like this. See, the garden is 15 meter long and 12 meter wide. Then the flower beds are 2 meter long and 1 meter wide like this. Okay, we have to find the area available for laying down a lawn. Okay, so we have to find this area. So area of the garden is 15 meter into 12 meter, that is 180 square meter. Area of one flower bed is 2 meter into 1 meter, that is 2 square meter. Total area of 4 flower beds is equal to 4 into 2, that is 8 square meter. Then area available for laying down a lawn is 180 square meter minus 8 square meter, that is 172 square meter. Shape A has an area of 18 square units and shape B has an area of 20 square units. Shape A has a longer perimeter than shape B. Draw two such shapes satisfying the given condition. So area of shape A is 18 square units. Then what is the condition here? We have to select dimensions in such a way that shape A has a longer perimeter than shape B. So we get a larger perimeter when the boundary of a shape is longer. Okay. When you extend the boundary of a shape, the larger its perimeter becomes. So we can select dimensions as area is equal to 9 into 2 is equal to 18. We can select length as 9 and width as 2. Then what's the perimeter? Perimeter is 2 into length plus width, that is 2 into 9 plus 2, that is 2 into 11 is equal to 22. Okay. Then what is the area of shape B? 20 square units. Here we have to select dimensions in such a way that its perimeter is less than the perimeter of shape A. So we can select dimensions as length is equal to 5 and breadth is equal to 4. So area is equal to 5 into 4, that is 20. Its perimeter is 2 into L plus W, that is 2 into 5 plus 4, that is 2 into 9, that is 18. So we can draw shapes like this. First rectangle, shape A with the length as 9 and width as 2. Then second rectangle, length 5, width 4. Draw a rectangle of size 12 units by 8 units. Draw another rectangle inside it without touching the outer rectangle that occupies exactly half the area. So, area of outer rectangle is 12 into 8, that is 96 square units. Then we have to draw another rectangle inside it without touching the outer rectangle, and its area is exactly half the area of outer rectangle. So, area of inner rectangle is half the area of outer rectangle, that is 96 by 2, that is 48 square units. So, possible dimensions of inner rectangle are 8 units by 6 units and 12 units by 4 units. Here, only rectangle with the dimensions 8 units by 6 units will fit inside the outer rectangle without touching it. Okay, so this is the rectangle, outer rectangle, this is the inner rectangle. Outer rectangle is 12 by 8 and inner rectangle is 8 by 6. A square piece of paper is folded in half. The square is then cut into two rectangles along the fold. Regardless of the size of the square, one of the following statements is always true. Which statement is true here? So we have a square piece of paper like this. Suppose its dimension is 10 by 10. This square is then cut into two rectangles along the fold. See, this square is 10 by 10. So, what is its area? Its area is 10 into 10, that is 100. Then its perimeter is 4 into 10, that is 40. This square is then cut into two rectangles along the fold. See, like this. So, its length of each rectangle is 10 and width is 5. Then, regardless of the size of the square, one of the following statements is always true. Which statement is true here? So, for each rectangle, what is the area? Area is 10 into 5, that is 50. What is perimeter? 2 into 10 plus 5, that is 2 into 15 is equal to 30. So, first statement, the area of each rectangle is larger than the area of the square. See, area of each rectangle is 50. Then, what is the area of the square? Is 100. Is 50 larger than 100? No. So, this statement is false. The area of two rectangles together is area of square. Then, second one, the perimeter of the square is greater than the perimeter of both the rectangles added together. So, here the perimeter of square is 40. Then perimeter of each rectangle is 30. So, perimeter of both rectangles, 30 plus 30 is 60. So, this statement is false. The perimeters of both rectangles added together is more than the perimeter of original square. Next one, the perimeters of both the rectangles added together is always 1.5 times the perimeter of the square. This statement is true. Perimeter of both rectangles together, that is 30 plus 30, that is 60, is equal to 1 and 1 by 2 times the perimeter of the square. Perimeter of the square is 40, that is 40 into 1.5, that is equal to 60. So, this is true. Next one, the area of the square is always 3 times as large as areas of both rectangles added together. See here, area of square is 100. Area of each rectangle is 50. This statement is false. The area of two rectangles together is equal to area of square. So, the summary of this chapter, the perimeter of a polygon is the sum of the length of all its sides. This is very important. Perimeter is the sum of the length of all its sides. The perimeter of a rectangle is twice the sum of its length and width. The perimeter of a square is
4 times the length of any one of its sides. The area of a closed figure is a measure of the region enclosed by the figure. Area is generally measured in square units. The area of a rectangle is its length times its width. So, area is length into width. The area of a square is the length of any one of its sides multiplied by itself. Two closed figures can have the same area with different perimeters or the same perimeter with different areas. Areas of regions can be estimated or even determined exactly by breaking up such regions into unit squares or into more general shaped rectangles and triangles whose areas can be calculated. Children, thanks for watching. If you like this video, please like, share and subscribe. We will see in the next video. The playlist for all subjects are given in the description box. Please go through it. Thank you.